Problem 5. Use IVT to show that e to the power of x and negative x, they intersect. They intersect, you just have to prove that. Okay, this means if and only if e to the power of x equals negative x has at least one solution. Okay, which just means e to the power of x plus x equals 0 has at least one solution. So what is your fx? This is your fx. So you have to find out two values such that two x's such that fa is greater than 0, fb is smaller than 0. So you can try f0 e to the power of 0 plus 0 1. f1 is of course positive, so now we want to find a negative number. So our x, we should give it a negative number, negative 1 e to the power of negative 1 minus 1. Okay, this part without calculation is 1 over 2.7 something, so it's definitely smaller than 1, right? So this part is smaller than 0. And fx, it's a continuous function. It's a continuous function on negative 1 and 0. Therefore, by intermediate value theorem, there exists a c between negative 1 and 0 such that fc is 0. Problem 6. F is continuous on the closed interval 0, 1, and fx is between 0, 1. So fx is between 0, 1. X is between 0, 1. Okay. So is it true that fc equals c for some c between 0 and 1? So what is fc equals c? It's this 45-degree line, right? So no matter how you draw the function, because this function will be in the box. Okay, sorry, this if it's a 45-degree line, this function is in your box. So this function is fc equals c, it's fx equals x. So let's call it gx equals x. And your fx is any function in this box. So let's draw some random function in this box. Right? You can see they intersect. We draw a random function. If it starts from 0, it's definitely intersecting, right? Because at this point, it is already intersecting. If we draw some function like this, it's intersecting. Right? If we draw some function like this, it's still intersecting. So no matter how we draw the function, these two functions are intersecting. So how do we prove this? Okay, so when you try the examples, you should get the idea. For example, if you start your function from here, you're already intersecting, right? You're already intersecting. So if your f0 is 0, right? G0 is also 0. If F0 is 0, then F0 equals G0 equals 0, right? G0 is Gx, right? Because Gx is just x, so G0 is just 0. So Fx and Gx, they intersect at point 0. Similarly, if F1 is 1, so if F1 is 1, right, they intersect, then F1 equals G1 equals 1, right? Then Fx and Gx they intersect at 1, 1. Right. So otherwise, first, Fx is a continuous function. Right, so Fx minus Gx is also continuous. Right, your Gx is x. Then what is Fx minus Gx? What is F0 minus G0? Because G0 is 0, and now F0 is strictly greater than 0, right? G0 is 0. So this part is greater than 0. Okay, F1 minus G1. G1 is 1. F1, you can see it from the graph. F1, it's strictly smaller than 1, right? Because we already know F1 is not 1. So F1 is strictly smaller than 1. So the difference is smaller than 0. Okay, so we can give this function a new name. We can call it hx. So hx is continuous. H0 is F0 minus G0 is greater than 0. Right, H1 is F1 minus G1 is smaller than 0. So by intermediate value theorem, there exists some C between 0 and 1 such that HC equals 0. Right? HC equals 0 means FC minus GC equals 0. Okay. So the proof is down.